So let's start with problem number 1. So the statement of problem: a flat plate having 1.5 meter into 1.5 meter moves at 50 km per hour in a stationary air of density 1.15 kg per meter cube. If the coefficient of drag and lift are 0.15 and 0.75 respectively, then we have to determine first one is the lift force, second one is the drag force, third one is nothing but the resultant force, last one we have to find out the power required to keep the plate in motion. So here if you read this problem statement carefully, so they have given that a flat plate of 1.5 into 1.5 meter, that means they have provided the value of area moves at 50 km per hour. That means they have given the value of velocity in a stationary air having density of fluid is nothing but 1.15 kg per meter cube, and here they have provided the value of coefficient of drag and lift are 0.15 and 0.75 respectively. That means value of CD and value of CL also they have provided. So we have to find out the value of lift force, drag force, resultant force, and power required to keep the plate in motion. So first of all we will write down the given data. So here given data is nothing but first one is the area of plate 1.5 into 1.5, that is nothing but 2.25 meter square. Then we are knowing the velocity of the plate in a stationary air, and that velocity is nothing but 50 km per hour. So convert that kilometer per hour in terms of meter per second. So multiply 50 by 1000 divided by 60 into 60 to convert that hour in terms of second. So 13.89 meter per second, that is nothing but the velocity of the plate. Then third one, density of air we are knowing 1.15 kg per meter cube. Coefficient of drag CD value is nothing but coefficient of drag 0.15, coefficient of lift 0.75. So first of all we will find out the value of lift force, drag force, resultant force, and power required to keep the plate in motion. So as we are knowing the formulas, so first of all lift force, so we are knowing the formula for calculation of lift force. FL is given by equation CL A rho U square upon 2, whereas CL is called as a coefficient of lift whose values 0.75 we are knowing is nothing but the projected area of that plane surface or plate, that is nothing but 1.5 into 1.5, that is nothing but 2.25 meters square. Density of air we are knowing 1.15. U, that is nothing but velocity of that plate we are knowing in terms of meter per second 13.89. Put all those values in this equation, we will get the value of FL. That value of FL will be in terms of Newton. So after putting all those values we will get the value of FL as a 187.20 Newton. So this is the value of lift force acting on that plate which is immersed in a stationary air. Then second thing we have to find out the value of drag force. So for calculation of drag force we are using the equation, that is FD is equal to CD into area into rho U square upon 2. Here also we are knowing the value of CD. Value of CD is 0.15. Area of the plate is nothing but 2.25. Density of air we are knowing. Then velocity of the plate also we are knowing. So after putting all those values, here also we will get the value of FD, that is nothing but drag force. That value of FD will be in terms of Newton. Then third one we have to find out the resultant force. So for calculation of resultant force we are knowing the formula, that is nothing but FR is equal to under square root of FD square plus FL square. So as we have calculated the value of FD and FL in terms of Newton, simply put those values of FD and FL in this equation, we will get the total force, that is called as a resultant force. So after putting those values of FD and FL in this equation, I will get the value of resultant force, that will be equal to 190.85 Newton. Last one is nothing but the power required to keep the plate in motion. So the formula for power required to keep the plate in motion is nothing but P is equal to force in the direction of motion into velocity divided by 1000. That value will be in terms of kilowatt. So force in the direction of motion, that is called as a drag force. So value of power required, or formula for power required to keep the plate in motion, P will be force in the direction of motion, that is nothing but Fd into velocity divided by 1000. Why we are taking this as a 1000? Because we require the power in terms of kilowatt. So simply formula of P is nothing but Fd into U divided by 1000. So as I am knowing the value of Fd, as I am knowing the value of U, and as I am dividing this Fd into U by 1000, then hence I will get the value of power in terms of kilowatt. If I am not going to divide this value of Fd into U, this value of Fd into U by 1000, then whatever value I will get, that will be in terms of watt only. Are you getting? So this is the solution of the problem number 1. Now we will switch to the second problem. The problem statement of second problem: a man having weight 90 kg force descend to the ground from an aeroplane with the help of parachute against the resistance of air. So this is the real life problem. There is one man whose weight is 90 kg force which descend to the ground from the aeroplane with the help of parachute against the resistance of air. The velocity with which the parachute, which is hemispherical in shape, whatever parachute is there, that is hemispherical in shape, comes down in 20 meter per second. So this is the speed of parachute. Find the diameter of parachute. Assume CD is equal to 0.5 and density of air is nothing but 1.25 kg per meter cube. So here there is one aeroplane. Through that aeroplane, one person whose weight is 90 kg force descend to the ground with the help of parachute. So the shape of that parachute is hemispherical, and that parachute along with person comes towards the downside direction with the speed of 20 meter per second. So we have to find out the diameter of parachute if CD, that is nothing but coefficient of drag, is equal to 0.5 and density of air is nothing but 1.25 kg per meter cube. So here suppose this is a man whose weight is 90 kg force. This is the parachute which is hemispherical in shape. So here as that parachute descend in the vertically downward direction, so here whatever air, surrounding air will be there, that will be considered as a stationary air, and as that parachute is moving in the vertically downward direction with a speed of 20 meter per second, that's why whatever drag force will be there, drag force means force which is in the direction of motion. So here if I am considering air as a stationary and as parachute is moving in the vertically downward direction, so drag force will be acting in the direction of motion of the air. So here motion of the air will be in vertically upward direction. So whatever value of drag force will be there, that will be in vertically upward direction. So in this problem, as they have not mentioned the weight of parachute, so if I am going to neglect the weight of parachute, so whatever weight of man will be there, that weight of man will be acting in the vertically downward direction. So here as that parachute is coming in the vertically downward direction, that's why whatever drag force will be there, that drag force will act in the vertically upward direction, and that value of drag force will be 90 kg force. So here first of all we will write down the given data. So weight of man is nothing but 90 kg force. Convert it in terms of SI unit. So for conversion of kg force into SI unit, that is nothing but Newton, I need to multiply by that 90 by 9.81, that is gravitational acceleration G. So here I will get the weight of man in terms of Newton, 882.9 Newton. Velocity of parachute, that is nothing but 20 meter per second. Coefficient of drag, they have provided 0.5. Density of air, that is nothing but 1.25 kg per meter cube. Now here area of parachute. So whatever area I am going to take, that is nothing but the projected area. So here as that parachute is hemispherical in shape, and as that parachute is coming in the vertically downward direction and motion of air is in vertically upward direction, so the projected area will be this much will be the projected area, that is nothing but the pi by 4 d square. That will be called as a projected area. So here projected area is nothing but pi by 4 d square, and here I have to find out the diameter of that parachute. So here, as parachute with man comes down with a uniform velocity u is equal to 20 meter per second, so the drag resistance will be equal to the weight of man. So here, as weight of man is acting in the vertically downward direction, drag force will be acting in the vertically upward direction, and value will be same. By neglecting the weight of parachute, and projected area of hemispherical parachute will be equal to pi by 4 d square. Therefore, whatever value of drag force will be there, that value of drag force is nothing but value of weight of that man. So value of FD is nothing but 90 kg force, that is nothing but 882.9 Newton. So here in this case, as I have to find out the value of diameter, so by using the formula of FD, as I am knowing the value of FD is given by equation FD is equal to CD area rho u square upon 2. Here I am knowing the value of FD, that is nothing but 882.9, value of CD 0.5, area is given by pi by 4 d square, density I am knowing, velocity of that parachute I am knowing, divided by 2. So here one equation, one unknown, that means here value of D is unknown term. So here I will easily get the value of D, and that value of D is nothing but 2.999 meter, that is approximately 3 meter, that is nothing but the diameter of that hemispherical parachute. So this is the answer of this second problem. So now we will switch to the last problem. So third problem is related to the third application, that is nothing but kite. So we are having one kite which is having the area as a 0.8 meter into 0.8 meter, and whose weight is 0.4 kgf. Convert that kgf in terms of Newton, that means I need to multiply that 0.4 by 9.81, so that will become as a 3.924 Newton. So a kite of 0.8 meter into 0.8 meter weighing 0.4 kgf, that is nothing but 3.924 Newton, assumes an angle of 12 degree with the horizontal. So whatever kite is there, that kite is making an angle with the horizontal as a 12 degree. The string attached to the kite makes an angle of 45 degree to the horizontal. So whatever string we are going to attach to that kite, so that string is making an angle of 45 degree with the horizontal, and kite is making an angle of 12 degree with the horizontal. So the pull on the string is 2.5 kgf, that is nothing but 24.525 Newton, when the wind is flowing at a speed of 30 km per hour. So here we have to find out the corresponding coefficient of drag and lift if density of air is given as a 1.25 kg per meter cube. So here, for better understanding purpose, we will draw first of all one diagram. So suppose this is a kite whose area is 0.8 into 0.8 meter, and whose weight is nothing but 0.4 kgf. So that is nothing but 3.924 Newton. So that weight of kite will always act in the vertically downward direction, and here we have assumed that in the problem assume an angle of 12 degree to the horizontal. So that kite is making an angle theta 1 is nothing but 12 degree with the horizontal, because here this axis will be considered as a horizontal axis. So this is nothing but theta 1, that is nothing but 12 degree. Now here that kite is connected with the string. So this is the string which is attached to that kite, and that string attached to the kite makes an angle of 45 degree with the horizontal. That means whatever this angle theta 2 is there, that is nothing but 45 degree. So the pull on the string, so here if I am going to draw the free body diagram, so here pull in the string will be acting towards the direction, and the value of that pull is nothing but 2.5 kg force, that is nothing but 24.525 Newton. When wind is flowing at a speed of 30 km per hour, so here speed of wind or direction of wind will be towards this direction. So wind is flowing towards this direction, then and then only that pull will be acting towards this direction. So speed of wind is nothing but 30 km/h. So here in this case we have to find out the coefficient of drag and lift. That means I have to find out the value of CD and I have to find out the value of CL. And density of air they have given as a 1.25 kg/m³. So first of all we write down this is nothing but the direction of air. So velocity of air is nothing but 30 km/h. So first of all we write down the given data. So projected area of kite is nothing but 0.8 into 0.8, that is nothing but 0.64 meter square. Weight of kite that will be acting in the vertically downward direction 0.4 kgf, that is nothing but 3.924 Newton. Angle theta 1 is nothing but angle made by kite with the horizontal, that is nothing but 12 degree. Theta 2 is considered as the angle made by string attached to the kite with the horizontal, that is nothing but 45 degree. So pull in the string, that is nothing but 2.5 kgf, so 24.525 Newton. Motion of air will be towards this direction. Velocity of air is nothing but 30 km/h. Convert it in terms of meter per second, that is nothing but 8.333 meter per second. And density of air is nothing but rho is equal to 1.25 kg/m³. So here in this case we have to find out the value of drag, coefficient of drag and coefficient of lift, that is value of CD and CL. So first of all, to calculate the value of CD and CL, first of all we need to calculate the value of drag force and value of lift force. So we are knowing the definition of drag force and lift force. So drag force is nothing but the force which is acting in the direction of motion. So as direction of motion is here towards the direction, so whatever force will be acting on the kite towards the horizontal direction, that will be called as a drag force. Now here basically two types of forces are acting on that kite. First force is nothing but weight of that kite which is acting in the vertically downward direction. Second force is nothing but the pull which is available in the string which is attached to the kite, and that string is making an angle of 45 degree with the horizontal. So here as weight is acting in the vertically downward direction, so its horizontal component will be equal to 0. But as pull is acting at an angle of 45 degree, so we can calculate the horizontal component of that pull. So that horizontal component of pull will be the value of drag force. So here, so drag force is nothing but force exerted by the wind in the direction of motion, that is along the x-axis direction. So here as weight component along the horizontal direction is equal to 0, so here only one component will be there, component of pull along the x-axis direction, and here that value along x-axis direction will be equal to p cos 45, because this is the adjacent side. So p cos 45, here I have considered the value of drag force towards this direction as a positive. P cos 45 is equal to 17.34 Newton, that is the value of drag force. Second one, lift force. So lift force is nothing but force which is acting perpendicular to the direction of motion. So here weight is already acting in the vertically downward direction, and second one is nothing but the pull which will be acting, or one component will be acting in the vertically downward direction. So if I am going to combine both the component, then I will get the total lift acting on the kite. So FL is nothing but force exerted by wind on the kite perpendicular to the direction of motion, that is nothing but along YY direction. So that is nothing but component of P in the vertically downward direction. Component of P in the vertically downward direction, that is nothing but P sin 45 plus weight of the kite. So here P sin 45, that is nothing but component of P in the vertically downward direction and weight of the kite, as both the forces, that means P sin 45 as well as weight, both are acting in the same direction, that's why the sign will be positive at both the sides. So here put the value of P sin 45 plus weight, I will get the value of lift force. Now after getting the value of drag force and value of lift force, simply by using the formula of FD and FL. Formula of FD is nothing but CD area rho U square upon 2, and formula of FL is nothing but CL area rho into U square upon 2. So here if I am going to consider formula for drag, so drag coefficient CD will be calculated as I am knowing the value of FD. Value of FD I have calculated. Value of area I am knowing 0.64. Density of air I am knowing. Velocity of the wind I am knowing. So 2 is a constant. So automatically I will get the value of CD. Similarly, in case of lift coefficient, to calculate the value of CL, as I have calculated the value of FL, as I am knowing the value of area, I am knowing the value of density, I am knowing the value of speed of wind, so easily I can find out the value of CL. So value of CD and value of CL, those are nothing but the answer of this question, and both will be the dimensionless quantity. So this is all about the problems based on the forces acting on immersed bodies, that is nothing but drag and lift. Thank you.